Examples on real number. Example number 1. Find supremum and infimum for the following set. Example number 1. The set A is equal to 1, 3, 5, 7, 9. So here the greatest lower bound, that is infimum, is equal to 1 and supremum is equal to 9. Number 2. A is equal to collection of all x such that 0 less than or equal to x less than or equal to 1. Here infimum is equal to 0 and supremum is equal to 1. Example number 3. The set A is equal to collection of all x such that 0 less than x less than 1. Here infimum is equal to 0 and supremum is equal to 1. Example number 4. A is equal to -1, 3, 2, 5, 7, 3, 2, 5, 7, 9, 12. Then here infimum of set A is equal to -1 and supremum of set A is equal to 12. Then example number 5. The set A is equal to -1, -1 by 2, -1 by 3, -1 by 4, and so on. So here the infimum is equal to -1 and supremum is equal to 0. Example number 6. A is equal to 1 by n belongs to n. If we write few elements of this set A, then A is equal to for n equal to 1 it is 1, for n equal to 2 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So it is a decreasing sequence. So here supremum of set A is equal to 1 and infimum is equal to 0. Example number 7. A is equal to -1 raised to n divided by n, where n is a natural number. Then again if we write the few elements of this set A, then for n equal to 1 it is equal to -1, for n equal to 2 it is 1 by 2, for n equal to 3 it is -1 by 3, 1 by 4, -1 by 5, 1 by 6, and so on. So here you can see all these elements are greater than or equal to -1, so infimum is equal to -1, and all these elements are less than or equal to 1 by 2, and therefore supremum of this set is equal to 1 by 2. Example number 8. A is equal to 1 plus -1 raised to n divided by n. N belongs to n is a natural number. So again if we write few elements of this set, there is 1 minus 1, 1 minus 1 for n equal to 1, then next 1 plus 1 by 2, then 1 minus 1 by 3, 1 plus 1 by 4, and so on. So here A is equal to 0, 3 by 2, 2 by 3, then 5 by 4, and so on. So if we write its decimal fraction, we get A is equal to 0, 1.5, then 3 by 2 may be 0.667, 5 by 4 is 1.2, and so on. So you can see here all these elements are greater than or equal to 0, so infimum is 0 and supremum is equal to 1.5, that is it is equal to 3 by 2. Supremum is equal to 3 by 2. The next set A is equal to collection of all A such that 1 by collection of all elements of the type 1 by 2 raised to n. N is a natural number. So here again if we write the few elements here, it is 1 by 2, 1 by 4, 1 by 8, 1 by 2 raised, then next is 16, 1 by 32, and so on. So here supremum is equal to the supremum, you can see here it is a decreasing sequence, so supremum is 1 by 2 and infimum is equal to 0. The next set a is equal to 3 plus 2 by 3 raised to n is a natural number. So again, now if we write the first elements of this set, it is 3 plus 2 by 3, then 3 plus 2 raised to 2, 3 raised to 2, then that is 2 by 3 raised to 2, then next 3 plus 2 by 3 raised to 3, and so on. So you can see here this is 2 by 3, then 2 by 3 raised to, it is a decreasing sequence. So the first element is 3 times 3 is 6, 9, 11 by 3, then next it is next is what, 2 by 3 raised to 2 by 3 raised to 2 by 3 by 3 raised to 2 is equal to 0.44. So this is 3.444. Then next 3 plus 2 by 3 raised to 2, 2 by 3 raised to 3 is equal to 0.29, that is 3.2963, and so on. So you can see here this sequence is decreasing sequence. So here infimum is equal to 3 and supremum is equal to 11 by 3, that is 3.6 something. 11 by 3 is equal to 3.667. So now the next example number 2, determine the sketch determine and sketch the set of pairs xy in R cross R is a real number set such that mod of x plus mod of y less than or equal to 1. So we want to determine a pair xy satisfying this condition. Okay, so now there are cases. Case number 1, if x is greater than 0 and y is greater than 0, that is if xy lie in first quadrant, in that case mod of x is equal to x and mod of y is equal to y, and so this equation, the equation mod of x plus mod of y less than or equal to 1 becomes x plus y less than or equal to 1. So now to draw this line, if we convert this into an equality equation, so here x is 0, y is 1, y is 0, x is 1. So if we draw this line, then here is the point 0 1 and here is the point 1 0. So and if we put the origin point here, then 0 plus 0 less than or equal to 1 condition hold satisfy, and therefore this is the region, all these region below the line satisfy the equation x plus y less than 1. Now case number 2, x is less than 0 and y is greater than or equal to 0. In that case mod of x is minus x and mod of y is equal to y, and therefore mod of x plus mod of y less than or equal to 1 becomes minus x plus y less than or equal to 1. Now to draw this line, if we convert this inequality to equality, we get if x is 0, y is 1, and if y is 0, x is equal to minus 1, and therefore here is the point minus 1 0 and here is the point 0 1. So this is the line passing through these 2 points, and if we consider the origin point, that is the point which is below this line, and if we put here, then 0 plus 0, which is less than or equal to 1, condition true, and therefore all the point below this line satisfy the equation minus x plus y less than or equal to 1. Now case number 3, if x less than or equal to 0 and y less than or equal to 0, that is xy lie in third quadrant, then mod of x is equal to minus x and mod of y equal to minus y. So mod of x plus mod of y less than or equal to 1 implies minus x minus y less than or equal to 1. Again, if we consider here x and y, then x is 0, then y is minus 1, and y is 0, then x is minus 1. So here again, if we, this is the point minus 1 0 minus 1, and this is the point minus 1 0, and if we consider this line, and if we consider again origin point, and if we put here, then 0 plus 0 less than or equal to 1, condition is true, and therefore all the point above this line satisfy the equation minus x minus y less than or equal to 1. Now the last case number 4, if mod of x plus mod of x is greater than or equal to 0 and mod of y is less than or equal to 0, this implies mod of x is equal to x and mod of y is equal to minus y. So in that case, so here x mod of x plus mod of y less than or equal to 1 implies x minus y less than or equal to 1. So here again, if we put the x is 0, then y is 1, y is minus 1, and y is 0, then x is 1. So again, this is the point 0 minus 1, and here is the point 1 0. So again, if we consider a line passing through these 2 points, and if we put origin point here, then again it satisfies the equation. So all the point above this line satisfy the equation x minus y less than or equal to 1. So if we combine these 4 cases in a single graph, then we get so this is a say this is xy plane r cross r. Here is the point 0 1, here is the 1 0, here is minus 1 0, and here 0 minus 1. So if we combine this, for the first line it satisfies this point, for the second line these are the point, for third line these are the point, and for fourth line this satisfies. This line represent x plus y equal to 1. Here this line represent minus x plus y less than equal to 1. This line represent minus x minus y equal to 1, and this line represent x minus y equal to 1. So these are the all points satisfying these equations. Okay, they are satisfying mod of x plus, this represent mod of x plus mod of y less than or equal to 1. So the next example number 3. Okay, let a is equal to x is a collection of all x, a real number x, such that 1 less than mod of x plus 3 plus mod of x minus 2 less than 7. Determine the set A. Now here the first case number 1, if 0 less than or equal to x less than 2, then in that case, since x less than 2 implies x minus 2 is less than 0, and therefore if x minus 2 is less than 0, then mod of x minus 2 is equal to minus of x minus 2, and therefore x minus 2 is equal to mod of x minus 2. And now if x for 0 less than or equal to x less than 2, mod of x plus 3, that is x plus 3 is always greater than or equal to 0, and therefore mod of x plus 3 equal to x plus 3, and therefore if we substitute this value here, then we get 1 less than mod of x plus 3 become x plus 3, and x minus 2 become minus of x minus 2 minus plus minus of x minus 2 less than 7, so here it is 1 less than this x minus x will get cancelled here. 3 minus 2 is equal to is 1, which is less than 7. So here sorry, x this minus become plus, so 3 plus 2 it is 5. 3 plus, you can see here 3, and because of this minus sign, minus plus, so 1 less than 5 less than 7, this condition is what? True. And therefore for 0 less than or equal to x less than 2, we get the first solution here. The first solution is what? X lie in from 0 to 2, this inequality hold. Now the next, if x is greater than 2, case number 2, if x is greater than or equal to 2, in that case x minus 2 is greater than or equal to 0, and therefore mod of x minus 2 is equal to x minus 2, and for x greater than or equal to 2, x plus 3 greater than or equal to 0, and this implies mod of x plus 3 equal to x plus 3. So if we substitute this value here in the original equation, the value of mod of x plus 3 is x plus 3, and mod of x minus 2 become x minus 2. So here we get 1 less than x plus 3 plus x minus 2 less than what? 7. So here x plus x is twice x, 1 less than twice x, 3 minus 2 is plus 1 less than 7. So if we subtract 1 from both the side, we get 0 less than twice x less than 6. So this implies 0 less than x less than 3. So here x, collection of all x in the interval 0 to 3 for the case number 2. Now for case number 3, if x if this number is negative, when it is negative, if x is greater than minus 3, if x is greater than or equal to minus 3, then here if it is equal to minus 4, x is equal to greater than, not less than minus 3, not greater than. If it is a less than minus 3, say it is minus 4, minus 5, then this is what? Minus 4. For minus 4 it is minus 4 plus 3 is minus 1. So if x is less than minus 3, less than or equal to minus 3, this implies x plus 3 less than or equal to 0, and this implies a mod of x plus 3 is equal to minus of x minus x plus 3. Now for x less than 3, or x less than or equal to minus 3, mod of x minus 2. What is mod x minus 2? Mod of x minus 2 is, again, x is negative, so this whole number x minus 2 is what? Less than or equal to 0. So mod of x minus 2 is equal to minus of x minus 2. So if we substitute this value, then it is 1 less than minus of x plus 3 minus of x minus 2 less than 7. So this implies 1 less than minus x minus 3 minus x plus 2 less than 7. So this implies 1 less than minus twice x minus 3 plus 2 is minus 1 less than 7. So this implies if we add 1 on both sides, we get 2 less than minus twice x less than 8, and if we divide 2 on both the side, then we get minus 2, then this is minus 1 greater than x greater than what? 4. if we divide by minus 4. Okay, so minus 4 less than x. So here we get the solution x lie between minus 4 to minus 1. Okay, and so if x is greater than less than or equal to minus 3, we get x lie between minus 4 to minus 1. And the last condition, the case number say 4, if x plus 3 is greater than 0. Suppose this number is greater than 0, x plus 3 is greater than 0, then we get x plus 3 is greater than or equal to 0, that is x is greater than minus 3. Then here, then mod of x plus 3 is equal to x plus 3, since it is a positive number, and mod of x minus 2. Now x is greater than minus 3, that is it may be a minus 2.5. So x is greater than minus, so no, here we want to consider a case again. If x is greater than minus 3, x is greater than minus 3 less than or equal to x less than what here 2, less than 2, minus 3 to 2. So here minus 3 to 2. So this number is what, for minus 3 to 2, this x minus 2 is what, less than 0. X minus 2 is less than or equal to 0, and this implies mod of x minus 2 is equal to minus of x minus 2. Okay, and therefore 1 less than mod of x plus 3 plus x minus 2 less than 7 becomes 1 less than x plus 3 minus x minus 2 less than 7. So here it is 1 less than x get cancelled here, and 3 minus 2 less, that is 5 less than 7. This condition again true, and therefore this also hold, that is minus 3 to 2. This also x lie in minus 3 to 2. So if we combine all these cases, case number 1, that is what is case number 1, 0 to 3. No, sorry, x is what, 0 to 2. X is 0 to 2. First it is 0 to 2 union. Next, for case number 2, x greater than 2, then it is what, x between 0 to 3. So x greater than 2, so here x greater than 2, so here 0 to 3, and x greater than 2, here it is 2, so x greater than 2 and less than 3, so it is what, 2 to 3. It is what, 2 to 3, then case number 3, for x less than minus 3, or here x less than minus 3, say here 0 and here minus 3. So x less than or equal to, what is given, x less than or equal to minus 3, x less than minus 3. So this is, if x is less than minus 3, the solution is what, minus 1 to minus 4. So here the solution is minus 4 to minus 3, union minus 4 to minus 3. And last, it is what, x greater than minus 3, so here is the minus 3, x greater than minus 3, and x lie between minus 3 to 2. So the solution is what, union minus 3 to 2. For close, again, for x is equal to 2, again want to include this 2 here for close interval 2. Also minus 4 we can also include, minus 3 is included here. So this answer is what, 0 to 2 union 2 to 3 union minus 4 to minus 3 union minus 3 to 2. that is minus 4 to minus 3, then minus 3 to 2, that is here if you see here it is minus 4 to minus 3, then minus 3 to 2, so minus 4 to minus 3, minus 3 to 2, 2 to then 0 to 2, 2 to 3, so the total solution will be minus 4 to minus 4 to 3. This is the total combined solution of this set. Since it is minus 4 to minus 3, then again minus 3 to 2, okay, then 2 to 3, so the total solution is what? Minus 4 to 3. We can check here whether it is true or false. Minus 3 to 3. What is given condition? 1 less than mod of x plus 3 plus x minus 2 less than what? 7. So for x is equal to 0, it is true. 3 minus 2, there is 2, 5 it hold. For x is equal to 0, this is true. Since it is 1 less than 5 less than 7. For x is equal to, say, an end point x is equal to 3, then 1 less than 3 plus 3 6, and 3 minus 1, 3 minus 1, that is 1. So 1 less than 6 plus, that is 7, less than 7. End point not hold. Sorry, it is open interval 1 to 4. And for x is equal to minus 4, for x is equal to minus 4, it is equal to again 1 less than minus 4 plus 3, it is 1, plus minus 4 minus 2, that is 6 less than 7. Again end point does not hold, so the answer is what? Minus 4 to minus 3, minus 4 to minus 4 to 3, open interval, not closed interval, minus 4 to 3. So now minus 4 to 3, again if we consider here x is equal to minus 3, then this is what? 3 minus 3, it is what? 0. 3 minus 3, 0. And minus 3 plus minus 5, 1 less than 2. For x is equal to 2, this is 0, 5, it is also hold. And for if we consider greater than number, say 5 plus 3, 8, 8 plus if we consider less than say x is equal to 4, the number which is greater than this interval, so it is what? For 4 it is 4 plus 3, 7, 7 plus 2, that is 1 less than 7 plus 2, 9 less than 7. This condition is what? False. And for x less than, if we consider, say, x is equal to less than say minus 6, then minus 6 minus 3 plus 3, it is minus 3, so it is 3, and plus 8 less than 7. This condition is also what? False. So the solution is what? Minus 4 to 3, open interval, minus 4 to 3.